Okay, so we're going to start, this unit is about radicals. So today we're going to just talk about simplifying perfect roots, whether square roots, cube roots, fourth roots, fifth roots. I wrote some of them on the board, some of the squares, cubes, and some of the fourth powers. Your calculator can also do higher roots. You just have to know how to enter that. But first, we just want to talk about what things are called, because when I refer to them, you need to know what I'm talking about. So first is n is the index. Okay, and that little number is going to be written up in the little open part of your radical symbol. That tells you what root you're taking. If there isn't one written, that's a 2, like a square root. We don't usually write it like we don't write an exponent of 1. But if it's anything higher than a square root, then you will have a number there. The x, the number under the symbol, is called the radicand. Whoops. The radicand, and then the actual symbol itself is called the radical. So when we read these, we need to, instead of calling it radical 2 or radical 3, we need to say square root, cube root, because a radical is just the symbol. The name of it is specific to the index. Okay, so the n is the index. When I say the index, that's what I'm talking about. The radicand is the number under the symbol, and the symbol itself is called the radical. Okay, so we're going to start with some perfect roots. That's all we're dealing with today is perfect roots. And the directions are going to tell us to simplify or state that the number is not real. We have not talked about the imaginary number yet, so we are not going to use it in class. So if that comes up, for now, at least until we get to that point, we'll just say it's not real. So the first one, number 1, is just the square root of 64. Remember, the index is not written when it is a square root. Just imagine that there is a 2 there. Okay, just like we don't write the exponent of 1. Most of these, or a lot of these, you will know off the top of the head. If not, you just look at your chart here. We're looking under squares because it's a square root. You look for 64, scroll over to its root, and the square root of 64 is 8. Okay. For number 2, we have a negative in front of the square root sign. So that is like -1 times the square root of 49. So we take the square root of 49, which is what? 7, and we multiply it by -1. So that would give me a -7. And that's when the negative sign is in front of the square root symbol, or in front of the root. Where's my negative sign on the next one? It's inside. Can we take the square root of a negative number? Can I multiply a number by itself and end up with a negative? No. So this is the case when the square root is under an even index. So a square root, a fourth root. When you have a negative under the symbol, we are not allowed to do that at this point. So this is the one that we're going to say is not real. So you can just put NR for not real. Okay. Yes, we can simplify that. But again, we haven't talked about the imaginary number yet, so we're not going to get into that just yet. Do we notice the difference on 4, 5, and 6? Yes, I have an index written, so that's going to change the root that I'm doing. My index is now a 3. That means I want to take the cube root of those numbers. So if you're not comfortable with your cubes, you have a list. You should have one from when we made it before. You can look to that list to help you determine what the root is. What is the cubed root of 27? 3. And then very similar to number 2, we've got a negative in front of the root. So it is a -1 times the cube root of 8. What is the cube root of 8? 2. And -1 times that would give me a -2. With 6, I do have the negative under the radical symbol, but this is a cube root, so it is going to be slightly different. Can I multiply a negative by itself 3 times and end up with a negative? Yes. So if your index is odd, you can take a negative root. If the index is even, that you would say it is not real. So we need to figure out what the cube root of 64 is, and then we just put a negative in front of it. So the cube root of negative 64 is negative 4. Yeah. Okay. So do we all understand the difference there? An even index is going to be not real if it's a negative under the radical symbol. An odd index will be a negative. So far, so good? Okay, now we've got some fourth roots. I want you to try this. I've got the list up on the board if you're not sure. You can also do those in the calculator. You just have to know how to enter the fourth root. But again, you also have a list you can look at. You can add those fourth powers to your list if you still have it. When we take our quiz next week, you will be able to use that. What is the fourth root of 16? 2. Okay, that's what I multiplied by itself 4 times to get 16. What about a negative fourth root of 16? Negative 2. And what about the fourth root of negative 16? Not real. Okay, the index is even, so therefore we cannot take a root of a negative number. Okay? So maybe if I start going too fast. Like y'all got this, so it's okay. All right, let's talk about some variables now. Sometimes people have a harder time with the variables. So what I do is I look at the index and I look at the exponent. So I'm taking the square root of x squared. So what is the index on the square root? 2, right? So this is what I ask myself. In order to find the square root of x squared, is how many times does that index divide evenly into that exponent? 1. So that means the square root of x squared is just x to the first. Also, you could just write that as x, right? Okay. So for number 11, I have the cubed root of x to the 6th. So I want to ask, how many times does the index 3 divide evenly into that exponent? 2. So the cubed root of x to the 6th is x squared. So you're multiplying it by itself 3 times. If I did x squared times x squared, that gives me x to the 6th, right? That's what a cube root means. Okay. Go ahead and try 12 then. You're looking for the fourth root of x to the 12th. Basically, you're thinking about splitting that exponent 12 into 4 equal parts. That's why we just divide. How many times does 4 divide into 12? 3. So the fourth root of x to the 12th would be x to the 3rd. Now you got numbers and variables together. So you can just think about them individually. Take whatever root of the number and then the root of the variable, and then you just multiply those as the answer. So for 13, I'm looking to simplify the square root of 16x squared. For 14, it is the cubed root of 64x to the third. And for 15, it is the fourth root of 81x to the fourth. What's the square root of 16? 4. And then again with the variables, your index, when it's not written as a 2, how many times does 2 divide into the exponent 2? 1. So the square root of 16x squared is just going to be 4x. What is the cubed root of 64x to the third? What's the cube root of 64? 4. And then the cube root of x to the third, 3 divides into 3 one time. Whoops. Try that again. So we get 4x again. What about the fourth root of 81x to the fourth? What's the fourth root of 81? 3. And then my index divides into my exponent how many times? 1. So the fourth root of 81x to the fourth is just 3x. With 16, we need to talk about this. There's a couple of different ways this one can be worked. Do you notice how the 8x is in parentheses and the 3 is on the outside? So the last section that we did was the exponents, and because that 8 and the x are in parentheses with the 3 on the outside, what gets the 3? Just the 8, just the x, or both? Both, okay. So it could be worked out like this. We could give, I'll keep the cube root for now. I could give the cubed to the 8 and also to the x. And I can either cube 8 or I can do the same thing I do with the variables. Look at your index. How many times does 3 divide into 3? Once, right? So that would be 8 to the first. And then we do the same thing with the variables. 3 divides into 3 one time. So that would be x to the first. And 8 to the first and x to the first is just 8x, yeah. Also, a different way you can look at it is because the 8 and the x are inside the parentheses, you could just go ahead and look at the index. How many times does 3 divide into 3? One time, so that would be 8x to the first, which is still just 8x, right? So that index, that 3, cancels out the exponent of the 3. No, see, if you look right there where we gave the exponent to the 8, and then we reduced it there, so 3 fits it. So because it's inside the parentheses, it wouldn't do anything to the 8. If that were not in parentheses, it would simplify differently. What is the cubed root of x to the 15th? X to the 5th, yep. Because 3 divides into 15 5 times. When you have a fraction under a radical, it is the same process. You just take the root of the top and the root of the bottom separately. So if I want to simplify the square root of x squared over 16, what I'm going to do is I'm going to take the square root of the numerator, the square root of x squared, and I'm also going to take the square root of the denominator. What is the square root of x squared? X. Okay, x to the first because 2 fits into 2 once. And what's the square root of 16? 4. Once you take the square root, you are done. Even though 4 is a perfect square still, we only take the root one time. We do not continue to take the root multiple times. Everybody okay with that? Okay, I got 2 more. Try those 2. With 20, just do each part individually. Do the cube root of -8. Then do the cube root of x to the 3rd. Then do the cube root of y to the 6th. Then you just multiply those together at the end. All right, number 19, I am taking the 4th root of x to the 4th over 16, which means I am going to take the 4th root of x to the 4th, and I'm also going to take the 4th root of 16. What is the 4th root of x to the 4th? X. And what is the 4th root of 16? 2. So I get x over 2. All right, and then 20, the cube root of -8 is what? -2. All right, and then 3 fits into 3 one time, so that'd be x to the 1st. And then 3 fits into 6 2 times, so that would be y squared. So I should get a -2x to the 1st y squared. Anybody have any questions? All right. This worksheet is your homework. We will get some non-perfect squares tomorrow. If it isn't, it is made. So if you look at your cube, so that tells you it's a cube. So you find 8, and then you scroll all the way around.